Okay, so the second, let me fix this. 3.2 is solving using substitution and elimination, okay? First, we're gonna solve using substitution. What do you think substitution means?
Substitution.
What will explain? Putting something in for something else. So if I have two equations, I'm going to solve one for x and or solve it for y. It does not matter what I solve it for. My advice to you is this. If there is an equation that has a 1 in front of one of the variables, like that second one says x plus 3y, why not just solve it for x there? Because then you can avoid fractions. If possible. Sometimes you can't avoid them, but if we can, we're going to do that. Right now?
Yes.
Yes. So if I change this first equation, I'm going to make this, that bottom equation red. I'm going to make this top equation green. Okay? And I'm going to rewrite this equation here to say x equals negative 3y plus 3. All I did was subtract that 3y over so that x is set equal to something, because now I'm going to take this and I'm going to plug it into the x of this equation. Okay? So that I get rid of the variable x and I only have y's to work with. So my equation up top is going to say 2, and then I'm plugging that whole equation in for the x, negative 3y plus 3, okay? And then plus 5y equals negative 5, because I can solve when there's one variable in something, okay? What do I need to do from here? What do you think I need to do from here? Do what? Distribute, yeah, distribute and then solve for y, okay? So I'm going to distribute that to, what's 2 times negative 3y? Negative 6y. What's 2 times positive 3? So I get negative 6y plus 6 plus 5y equals negative 5. Now what do I need to do? Subtract 6 and combine these like terms, okay? So if I subtract 6 and I combine negative 6y and 5y, what do you get there when you combine those two? Negative y equals negative 11, yeah? Divide by negative 1 and y equals. Now, I'm not done. I need to substitute this back in. The best way to substitute this back in is to sub it in for that equation that you just rearranged, because now it's going to say x equals, okay? So I have x equals negative 3 times 11, and I always do mine in different colors, so feel free to do yours on your homework in different colors, because later on in the year we're going to have 3 variables, x, y, and z, meaning 3 equations, and it's going to get very complicated and confusing if you don't color code things, okay? So you get x equals negative 33 plus 3, which gives me x equals what? Negative 30. So your solution needs to be written like this. Negative 30, 11. That is using substitution. Okay? Can you handle that? I think you can. I personally love solving equations using substitution and elimination because I prefer not to graph them. Caden's like,
Graphing sucks.
yeah, well, you're going to hate algebra too. Okay, so that's how we're going to solve using substitution. It's very simple. Solve one equation for x or y. It does not matter which variable you solve for, and then you plug it into the other equation where that variable is. Then once you get that solution for x or y, you plug that back into one of the other equation, and you'll get which one you are missing, okay? If the x or y has a 1 in front of it, I suggest solving for that. It's the easiest. Now, sometimes there might be fractions because we can't always avoid them. So don't stress if there is, you just have to multiply them. If you want to change the fraction into a decimal and do it that way, you can. Or you can leave it as fractions, okay? It's up to you. That's what you gotta try to see. That is using substitution. Let's talk about my favorite way, which is elimination. I underlined some stuff already. The elimination method. The goal of this method is to eliminate a variable. So I'm not subbing stuff in, I'm literally getting rid of one of the variables so that I can solve, okay? So So the first step is multiply one or both of the equations by a constant to obtain coefficients that differ only using sign for one of the variables. Meaning this, if my equation back here, okay, this has a 2x right there, right? If I multiply this whole bottom equation by negative 2x, then 2x and negative 2x will cancel if I add those equations together, yes? That's how we want to eliminate something. Sometimes you might have to multiply both equations by the opposite of what they are. It depends, okay? So we want to eliminate by getting rid of a variable. Then you're going to add the revised equations and then you're going to substitute in the values. So let's take a look at this. I have 3x minus 7y equals 10, and I have 6x minus 8y equals 8. Do you notice how there is not a 1 in front of the x or y? That's why elimination is easier for this, okay? What is in front of my x's are a 3 and a 6. What's in front of my y's are a negative 7 and a negative 8. Is it easier to multiply the x's by something or the y's by something to get them to the same number? The x. And which equation do you want to multiply by? Or which equation do you want to multiply? The 3 or the 6? The 3. And what are you going to multiply by? Okay, negative 2. Because the bottom one is a positive 6, we want to make the top one negative. Okay? So we're going to take this equation, I'm going to make this one blue, and we're going to multiply this whole thing by negative 2. The whole thing. Meaning, I am distributing this negative 2 into each piece. What's negative 2 times 3x? Negative 6x. What's negative 2 times negative 7? Positive 14y. And what is negative 2 times 10? Negative 20. So do you see how I did it by the whole equation? Okay? Now I'm taking these two equations and I'm adding them together. This is also why I wrote it underneath, because now I can just add them. I didn't have to rewrite that other equation. Okay? What is 6x minus 6x? 0. What is negative 8 plus a positive 14? Negative 8 plus a positive 14. So 14 minus 8. 6? 6y, correct? And then what is 8 plus negative 20? Negative 12. Now how do I solve for y from here? Divide by 6, and y equals what? Negative 2. What am I going to do with this? What am I going to do with negative 2? Plug back in. It does not matter what equation I plug it into. I can plug it into the one that I redid. I can plug it into one of the originals. My suggestion is always plug into original because it's smaller numbers to work with. Okay, so I'm going to take that top equation of 3x minus 7, and I'm going to plug in for that y a negative 2, and it's all set equal to 10, and I'm going to solve. So 3x, and what's negative 7 and negative 2 together? Equals 10, and then I subtract 14, correct? And you get 3x equals, what's 10 minus 14? And x divided by that, and x equals what? Negative 4/3. So, my solution, the way I have to write it is negative 4/3, negative 2. You write it like an ordered pair because it is 1. That's where those two lines cross. Okay? Can you understand this so far? I want to see something. No, I want to see what others. Okay, good. Okay. So, word problem, but not a hard word problem. To raise money for new football uniforms, your school sells silk screen T-shirts. Short sleeve T-shirts cost the school $5 each, are sold for $8. Long sleeve shirts cost the school $7 and are sold for $12. The school spends a total of $2,500 on the T-shirts and sells all of them for $4,200. How many of the short sleeve T-shirts are sold? We have to create two equations, then use substitution or elimination to solve these. I'm telling you that ahead of time. You have to create two equations. Do you know how to do it? Okay, what do you think, Caden?
5x plus 7y equals 2,500.
Okay, so you're gonna take 5x, the number you spent on t-shirts, right, the short sleeve, plus how much you spent on long sleeve, and you're gonna set it equal to how much you spent total, which was 2,500, right? And then my second equation is what?
8x plus 12y.
How much I
equals
charged.
4,200.
How much I charge for short sleeve, plus how much I charge for long sleeve, and how much money I got in total, yes? Does that make sense where I got those two equations from? Okay, do you wanna do substitution or do you wanna do elimination? I would do elimination, here's why. If you do substitution, you're going to have fractions, period. Because it's gonna say like x equals negative 12y, like, okay, and you're gonna have a divided by 8, you're probably gonna have fractions at some point, okay? So I would do elimination. Now, to do elimination on this, you have to multiply both equations, okay? Because I can't just multiply one or the other, because these are not multiples of each other, yes? And these are not multiples of each other. So if I'm you, I multiply this top one by 8 and the bottom one by 5, just get rid of the x's. Because I'd rather do that than 12 and 7, if that makes sense.
What did that must be negative?
Yeah, so I'm gonna make this one negative 8, okay? What's negative 8 times 5x? That should be easy. What's negative 8 times 5x? Yeah, negative 40x. What's negative 8 times 7y? 56, is that what? Is it 56? I think it is. Negative 56y. And then what is negative 8 times 2,500? Negative 20,000.
Oh.
Now we're gonna take this bottom one and we're gonna multiply it by positive 5. What's 5 times 8? 40, that's good because that should come out to be what we want it to be. If not, we did something wrong to start with. What's 5 times 12? 60y. And what is 5 times 4,200?
Wait, I can do this in my head.
Okay,
7,000. Wait, wait.
0, 0, 5 times 2 is 10, 21. Okay, now I simply add these together, yeah? Negative 40x, positive 40x, cancels, beautiful. Negative 56 and positive 60 gives me 4y, and negative 20,000 and positive 21,000 gives me. Now you divide this by, and y equals what? 250? Yes, 250, because it's like quarters, right? That's how I do it.
Yeah.
So 250. So we sold how many long sleeve shirts? 250 long sleeve. Okay? That's that part of the answer. Now, what do I have to do with that 250? I would plug it into one of our original equations without that 8 multiplied in because it's going to be smaller numbers. Okay? So let's do that. Let's say 5x plus 7 times 250, right? Equals 2,500. Okay, so I get 5x plus what's 7 times 250? Yeah, 1,750 equals 2,500, right? So subtract 1,750 from both sides, correct? And you get 5x equals what? Yep, and then divide it by 5 and you get what? $150
I told you it was C.
short sleeve. Okay?
It's always C on these ones.
Okay, so we have 250 long and 150 short sleeve. Do you understand how we got there? You understand that you have to make 2 equations first and then you choose substitution or elimination, whichever one's easier for you. Okay? Now, let's look at this last slide and it's deciding which one we're going to choose. Solve the linear system. On this first one, are you going to use substitution or elimination? Why substitution? Because there's a 1 in front of the x. It makes it super simple. Okay, so we changed this equation to say, x equals 2y plus 4, yeah? And we sub it in for this x over here. So I have 3, and then I would have times 2y plus 4, yeah? Minus 6y equals 8. Distribute that. You get 6y plus 12 minus 6y equals 8, yeah? What's 6 minus 6y? 6y and negative 6y gives me 0 equals negative 4. What does that mean? When I get 0 equals negative 4?
Wrong.
Well, it's not wrong. What does it mean about those lines? Yes, Kaden, but they're probably parallel because there is no solution. So when I get something that doesn't equal the other side, you say, no solution. Can you handle that? Okay, no solution. Makes it nice, I don't have to plug anything back in. Up here, what do you think we're gonna do? Elimination or substitution?
But we just did.
How do you know what? If you wanna do substitution, you want there to be a single x or a single y. If there are numbers already with all of them, do substitution, or do elimination, yeah, because it would be easier. You wanna do elimination, so what do we wanna multiply by? Now listen, here's what I suggest, okay? You don't have to multiply the top by 14 and the bottom by 4, okay? Do 14 and 4 have a least common multiple? Okay, what can they both multiply to be 2? No, not what can go into them, not least common factor, least common multiple. What can both of them multiply to? If I multiply 14 by 2, you get what?
28.
Can 4 get to 28 if you multiply it by something? By what? 7. So let's multiply both so that they're to 28. Does that make sense? Okay, it makes it easier. So if I multiply this top one by positive 7, because this is already negative, and I multiply this bottom one by 2, it makes my life easier. So 7 times 4 is positive 28. What's 7 times negative 10? 7 times negative 10. Negative 70. And what is 8 times 7? 56. We just did that one. What is 2 times negative 14? Negative 28. What is 2 times 35? Plus 70. And what is negative 28 times 2? Negative. Now watch this. This is a special case one. What happens when you do 28x plus negative 28x? You get 0. What happens when you do negative 70 plus 70? You get 0 on this side. What happens when you get 56 plus negative 56? What happens when it's 0 equals 0, or 1 equals 1, or 12 equals 12? No, it's not no solution. It's infinite solutions.
I said that first. Oh, we know both are such good students.
So, this would be lines that map on top of each other, right? The same line. These would be, no solution would be parallel. Infinite solutions would be the lines that are graphing on top of each other. If you get a set point, that means the lines cross once. Okay? Does that make it easier? I think that makes it, personally, I think that makes it easier. I like doing math better than I like graphing. I like doing algebraic equations better than I like graphing.
For sure.
Okay, let me give you some homework. Substitution and elimination.